Hello, my name is Alan Mateja. My group, which included Jack Federico, Charlie Hill, Mitchell Kellerman, and myself, created a trebuchet which we named the Catapult 3000. Today we are going to walk you through the design process, the construction process, and the testing of the trebuchet. The problem definition. Our goal in building a trebuchet was to design the most efficient trebuchet by using the equation seen here on this slide. On this slide, you will see our design parameters. Most notably, the trebuchet had to fit into a 1 foot by 1 foot by 1 foot cube. The design of the trebuchet. When designing the Catapult 3000, our group wanted to keep in mind our three core values: violence, speed, and intensity. We wanted to maximize the violence of our counterweight falling, to maximize the speed of the long arm and the sling, to ultimately have a better launch. Now we will talk about the base. The base was designed to be 4 pieces that would fit together in order to form one solid piece that would act as the base for our trebuchet. The pieces are the front, 2 back pieces, and a chute. When these pieces are put together, the base is 3.5 inches wide, 1/2 inch tall, and 12 inches long, and the chute has a diameter of 1 inch. Now we're going to talk about the vertical supports for our trebuchet. The vertical supports are made of 2 pieces that fit into each other. These pieces form 2 A-braces on the vertical beam in the center. The vertical beam fits into the base by a square hole in the base. The 2 other sides of the A-brace touch the base but are not fitted into the base. The vertical supports are 12 inches tall, and the pivot is located near the top of the vertical supports. Now we are going to talk about the weight holder and the arm. The weight holder was created by creating a cradle for our weights, which are a hexagon shape. The weights fit perfectly into the cradle. The weights were held 5 inches off the arm, and the arm was 10 inches long. A pivot was made in the arm 1 inch from the side of the arm, and the sling was located on the end of the side of the arm that was 9 inches long. The weights were located on the side of the arm that was 1 inch. Now we are going to discuss the assembly of a trebuchet. On the left is a blown up assembly drawing of the trebuchet, and on the right is a picture of what the trebuchet was designed to look like when all the pieces are put together. There is another vertical support that is not pictured in both pictures. Now to discuss the launch mechanics. The launch mechanics were designed for the trebuchet was that an eye screw would come off a metal rod as the arm whipped around. This part of the design was influenced by the Mythbusters video on making a trebuchet named How to Build a Trebuchet on the Science Channel YouTube channel.
This is Jack Federico covering the construction process. Our model was unique in that it was 100% 3D printed. It fit together almost like Legos. It was held together by super glue and hot glue. And the reason we did this was originally our pieces would not fit on the build plates, so we had to cut them in half. Our base we separated into 2 pieces, and the trough as well we separated. And our upright columns we also separated into 2 pieces. And we did this also because we wanted to prevent warping, because longer pieces tend to warp easier. And speaking of warping, we did have a lot of problems with this, and we did have to throw away a couple pieces because they were unusable. In this left picture here, you can see below the E in intensity a piece that was warped but not badly enough to throw away. It still fits together, but you can see it definitely, there's a difference there. And, the pieces don't fit together perfectly. And in the right picture, you can also see the top of that upright column is slightly warped, but we were still able to get the rod through. The next thing I'd like to talk about is the sling, which we had the most trouble with during construction. During testing, we couldn't seem to get the release angle right. So we tried many things. We tried lengthening and shortening the strings. We tried angling the rod both ways that sticks out of the throwing arm that the eye screw slides onto. We tried adding tape to the cloth to make it more rigid because we did have an issue with the sling kind of swallowing the marble. And we also tried lengthening the trough with a piece of cardboard. So during all these fixes that we were making, we also noticed something in our slow-mo footage, and that is that the counterweight would sometimes hit the sides of the upright columns. And to alleviate this, we used spacers that we made out of 1/4 by 1/4 inch balsa wood. And we used the drill press to drill holes in them, and we hot glued them to the inner sides of not only the weight holder upright pieces, but also the upright columns. One other thing we did to keep the uprights of the weight holder straight and sturdy was, as you can see in this picture, we added a screw that went across them there to add rigidity.
Here is a video of our trebuchet in action. Now I'm going to discuss the performance of our trebuchet. In the simulation, our trebuchet was able to achieve a distance of 43 feet with 93% efficiency. In real-life testing, our trebuchet only achieved a distance of 15 feet with a 60.72% efficiency. Some of the pluses from our testing: our trebuchet had a great potential energy with our mass, which weighed about 5 pounds, and the supports were able to hold that mass as it swung through. Some of the negatives from our performance: our sling was poorly designed and would often eat the marble and only threw it out on the ground, and there was also not enough space for the counterweight to go cleanly through the 2 vertical supports. More performance issues was that the axle at the pivot point started to bend because of the massive amount of weight that was held on it, and that our trough was very short, so that the marble was not always in contact with the trough. We fixed some of these problems by adding spacers in there for the counterweights. We redesigned the sling a couple of times. We replaced the axle, and we extended the trough with a piece of cardboard. All of us would like to thank you for watching our video on the Catapult 3000.